New York's first skyscrapers had a problem that no one talks about. The steel was there, the elevators were there, the investors, the architects, the ambition, all there. But above the 6th floor, the water stopped. Not sometimes, not in emergencies, always. A building could rise 12 stories, 15, 20, and every faucet above the 6th floor would run dry. Every toilet would stop working. Every fire standpipe would sit empty. The skyline almost ended there, 6 floors up, for want of water pressure. In the 1880s, New York was building faster than ever before. Steel frame technology and the passenger elevator had broken an invisible ceiling. Buildings could now rise above 6 stories and still be practical. Upper floors, once nearly worthless, became profitable. Developers raced upward. But the city's water infrastructure had been designed for a different New York, a low-rise city fed by the Croton Aqueduct. Supplying Manhattan since 1842, the system reached roughly the 5th or 6th floor, no higher. Every building that rose above that threshold faced the same crisis: water for drinking, sanitation, and the fire protection systems that building codes were beginning to require. Something had to change. What no one had figured out yet was who would answer it, and from where the solution would come. The answer came not from an engineer's office, but from a cooperage on the Lower East Side. William Dalton was a barrel maker. He had been building wooden vessels, barrels, vats, casks, since before the Civil War, using techniques that traced back centuries through the cooperage trade. In 1866, he founded his company on the Lower East Side, supplying the city's shipping and food industries with containers built from white oak staves. But what does Dalton have to do with the story of skyscrapers? Water pressure works in 2 directions. City mains push from below, gravity pulls from above. New York's municipal mains reached roughly 6 floors. Beyond that, gravity wins. The solution was a rooftop tank. Store water at the top, let it fall. Every floor below served at consistent pressure without depending on the street main. When the city mandated that all buildings over 6 stories be equipped with rooftop water tanks, Dalton recognized what the problem required. Not new technology, old craft applied to a new height, the same joinery, the same stave construction, the same physics that had kept barrels watertight for centuries, now holding 10,000 gallons above the Manhattan skyline. The rooftop tanks were not simple containers, built from white oak staves, the same slow-grown timber used for wine barrels and ship holds. They were shaped and fitted dry and bound with steel hoops. The staves had to be shaped and fitted so precisely, each edge beveled at an exact angle, that the wood sealed itself under pressure. When water entered, the wood swelled and like this sealed itself. No nails, no glue, no sealant. If a single stave was cut wrong, the tank would weep. Under 10,000 gallons of head pressure, a slow leak became a structural failure. Everything was cut and fitted in the workshop, then carried to the roof in pieces. The coopers assembled the tank in place, stave by stave, hoop by hoop, entirely by hand, on a rooftop platform. A standard tank for a 12-story building held between 5 and 10,000 gallons, up to 80 tons fully loaded. That weight had to be calculated into the structural frame before a single stave was laid. But the tank alone was not the complete answer. Every building with a rooftop tank needed a steam-powered booster pump in the basement, running continuously, lifting water to the roof. Pipe diameter had to be sized precisely. Too narrow, and the upper floors ran dry. Too wide, and lower floor fixtures cracked from overpressure. In taller buildings, 15 stories and above, a single tank created a different problem. Pressure at the ground floor, fed by a tank 14 stories overhead, was too high. The solution was zoning. Multiple tanks at different heights, each feeding a designated range of floors. Waste disposal required its own system, ventilated stacks and trap seals at every fixture. Without proper venting, flushing a toilet on the 12th floor created a siphon effect that emptied the trap seals below. Once the seal failed, sewer gas entered the building. In 1893, a New York inspector documented exactly this. 4 consecutive floors of a newly opened hotel, all reporting the same smell. The vent stack had been left out to save cost. Reinstallation exceeded the original estimate by 300%. William Dalton died in 1896. His widow sold his business, the lumber, the tools, and the goodwill, to a Polish immigrant he had hired 2 years earlier named Harris Rosenwach. The sale price was $55. That company is still operating today. By the early 20th century, 3 firms in New York built and maintained the city's rooftop tanks. All 3 were family businesses. All 3 traced their origins to the cooperage trade. The knowledge that made skyscrapers possible was never written down in an engineering manual. It lived in the hands of barrel makers. The difference between a functional tank and a failed one was not visible at installation. A tank built by a skilled cooper would seat correctly, swell evenly on first fill, and hold pressure for 30 to 35 years. A tank built with imprecise joinery might not survive a single New York winter. Water expanding inside a compromised stave splits the wood from within. The blizzard of 1888 exposed this across the city. Water systems in tall buildings froze and fractured. Standpipes burst. Fire protection failed at the moment it was most needed. The buildings that survived were the ones whose tanks had been built by people who understood that wood under water pressure behaves differently than wood in dry air. That understanding could not be purchased. It had to be accumulated. By the early 20th century, New York's rooftop tanks had become part of the city's visual identity. Artists noticed them. Ashcan school painter John Sloan included them in his street scenes. Edward Hopper painted their silhouettes against winter skies. What they were recording, without necessarily knowing it, was infrastructure with no equivalent anywhere else. A technology born from a medieval craft, adapted in a cooperage on the Lower East Side, and installed by hand on the tallest buildings on Earth. The city built upward. The barrel makers made it livable. By the 1950s, electric pumps had replaced steam-driven systems in most buildings. Pressure-regulating valves eliminated multiple tank zones. Fiberglass and welded steel displaced wooden tanks in new construction. The craft disappeared through attrition. The last generation of commercial tank coopers retired without successors. In New York, a small number of specialist firms continued the tradition. As of the early 2000s, an estimated 10,000 to 15,000 rooftop tanks remained in service. The majority wooden, many original to buildings constructed before 1940. The skyscrapers rose because of steel and elevators. They worked because of a barrel maker from the Lower East Side, who recognized that an ancient craft had one more problem left to solve. The tanks are still up there. Most people never look. The modern world stands on foundations few still remember. If you'd like to see more of these hidden systems documented, consider subscribing, and tell us which forgotten craft should we cover next.